Hello, my name is Daryl Da Silva, and today we are going over the experiment, isolation and characterization of a natural product, caffeine. The first part of the experiment was boiling the tea leaves. The student dissolved sodium carbonate in DI water and heated the mixture in a round bottom flask. The sodium carbonate acted as a base that stopped the tannins from dissolving with the caffeine. Tannins are organic molecules in the tea leaves other than caffeine. The base turns the tannins to a salt, which are not soluble in dimethyl chloride. He then added the tea leaves and boiled for 10 minutes until the tea was extracted from the leaves. As you can see right here. And then he separated the tea leaves from the tea extract through flask filtration. One of the biggest unavoidable errors was flask filtration. The boiled tea extract would get the funnel clogged and we would have to use a different filter paper, which in theory did contain caffeine in it. The tea leaves were also still very moist, which meant that we still had caffeine inside the tea leaves. This made it impossible to obtain the full amount of caffeine from these tea leaves. The next part of the experiment is the extraction of caffeine. The student then put dichloromethane and the tea into a separatory funnel. He then shook the funnel to make sure all the dichloromethane bonded with the caffeine. Since both are nonpolar and caffeine contains two ketone oxygens, this allows caffeine to bond with the dichloromethane. The mixture then separated into two different layers. Since the dimethyl has a higher density, it stays on the bottom with the caffeine. The other organic materials stay on the top layer, bonded to the water. The dichloromethane and caffeine solution was then extracted from the rest, which was a clear and colorless solution right there in the corner. The next part of the experiment is using a drying agent. The student added sodium sulfate to the dimethyl chloride and caffeine mixture. Sodium sulfate is a very polar molecule which bonds with the polar water. This allows the solution to be waterless, or also known as dried. Now here's the sodium sulfate with the dichloromethane and caffeine solution. After, the student has to filter out the sodium sulfate from the caffeine and dimethyl chloride solution. The student used pipettes with cotton and separated the sodium sulfate. The student then had to evaporate the dimethyl chloride from the caffeine. The boiling point of dimethyl chloride is 39.6 degrees Celsius. So the student only had to use a steam bath to boil the dimethyl ether to make it evaporate from the caffeine. In the end, the student obtained 0.031 grams of crude caffeine. The crude caffeine was then put in a sublimation apparatus to further purify. The apparatus consisted of a vacuumed flask, a Bunsen burner, and ice to lower the temperature. The flask was then vacuumed to lower the pressure inside the caffeine, which lowered the boiling point. The ice also lowered the boiling point, allowing the caffeine to further sublime in the apparatus. The student then received about 0.02 0.0225 grams of caffeine after sublimation, which you can see right here on the right side. Pure white caffeine, 0.0225 grams. Next, the student had to test the melting point of the caffeine to figure out how pure the caffeine was. The student then tested caffeine using a melting point apparatus. The caffeine melting point was 234 to 236 degrees Celsius. My caffeine melting point was 223 degrees Celsius. The change in temperature, the change in melting point, is due to technical errors like contamination from the drying agent or other organic materials that probably were not separated properly. But the student did get pretty close to that 234 to 236 degrees Celsius, which is actually the pure caffeine. Results. The student initially had 1.999 grams of tea leaves. The student then obtained 0.031 grams of crude caffeine. And after sublimation, the student had 0.0225 grams of caffeine. And last but not least, the melting point. The student received 223 degrees Celsius for his melting point of caffeine. And that's the end of the presentation. Well, thank you. This is Daryl Da Silva, and I will see you guys later.